So we'll look at question 7, and this is out of 4.1. Now these are rules of exponents. And these you really have to be careful about the rules because they're a little bit different with exponents. Because remember, when we multiply, the exponents add. When we divide, they subtract. When we have parentheses, we distribute through just like multiplication. So question 7 is we've got 5 over 2 to the negative third power. So what we can do, and there are many different ways of looking at a problem like this one, I'm going to go ahead and distribute through that negative 3. You could also just simply flip the fraction over, but I'm just going to distribute it through, just so we understand the steps that are involved. And then what do we know about these negative exponents? Well, we do not want negative exponents in our answer. So this 5 to the negative third power, it's going to go down below. And this 2 to the negative third power, what about it? It's going to go up to the top. So then we're left with, when they move, they become positive. Then we're left with 2 cubed on the top, 5 cubed down below. 2 cubed is not 6. 2 cubed is 8. 5 cubed is, again, not 15. 5 cubed is 5 times 5, which is 25, times another 5 makes it 125. So your answer on that one would simply be 8 over 125. So be careful with those exponents. A lot of times students get in a hurry and forget things, and they try to multiply. On those exponents, you take them, write them out if you need to. Replace them with the numbers if they're small. Now, if your exponent is much larger than 4 or 5, you'll leave the number as it is. So if that would have been something like 5 to the 5th power, you could leave it as 5 to the 5th. That one's small enough that we can simply break it down. Negative makes that fraction flip over, and then we work with our powers after that. Question 10, we're going to be using the product rule. So for question 10, we have m to the 10th, m to the 5th, m to the negative first power. Now, very easy to work this one out. We need to remember, though, when we get our answer, we do not want negative exponents. So if it's got a negative exponent at the end, you make it a fraction. There's no parentheses, right? So we're going to apply the product rule. So we add all those exponents together. So minus 10 plus 5, that's a minus 5. Minus 1 makes it m to the minus 6th power. And can we leave a negative exponent? No. So what do we do with that? That goes down below, and that becomes 1 over m to the 6th. So do not leave it as a negative exponent. If it's a negative exponent, rewrite it as a fraction. So we just simply added those numbers together for the powers, rewrote it with a positive exponent. The next ones are the more difficult ones. These require all the rules, quotient, product, power rule put together. So we're now going to look at question 13. And we'll take our time when we work out question 13. And there are different ways of approaching this particular question. When I see a question like question 13, what I'm going to do is I'm going to try and reduce down my parentheses first. So let's look inside that parentheses. And inside the parentheses, I have 10 t to the negative fourth over t squared. So that 10 stays there. Now, what about the exponents? We're dividing. So what do we do with the exponents? They subtract, right? So you subtract your exponents. So that's going to be t to the minus 4 minus 2. And so that piece comes down to be t to the negative 6th power. And you don't have to worry about negative exponents until the very, very end. You can move them around earlier if you want, but normally I just leave them until the very, very end. Now we have parentheses. So we're going to go ahead and distribute that negative 4 through. That makes it now 10 to the negative 4th power. Negative and negative, when we have parentheses, remember these multiply due to the power rule. So that's going to be t to the 24th power, because 6 times 4 is 24, times 11 over t to the negative 4th power. Now we have to work with this, and we have to work with these negative exponents at some point. So let's go ahead now and look at 10 to the negative 4th power. 10 to the negative 4th power, that would be 1 over 10 to the 4th. And what about 10 to the 4th? 10 to the 4th power is 10 times 10 times 10 times 10, which that comes out to be 100 times another 100. I believe that's going to be 10,000. So that would be 1 over 10,000. I always like to work with those coefficients first and then see what we're dealing with after that. So I just took that 10 to the negative 4th, I made it a fraction. And then down below, I went through and multiplied. So 10 times 10 is 100. The next to is another 100. Multiply those together, we get our 10,000. So let's go ahead and rewrite that now. So let's see what we've got. We've got the 11. It's going to stay there. We've got a t to the 24th power on the top. Down below, we've got 10,000. So that's our 10 to the negative 4th power. We rewrote it. Remember, it's going to go down below. And what else do we have with it? We have a 10 to the negative 4th power. So we just do it step by step, slowly work your way through all of this. And our last step is going to be t to the 24th over t to the negative 4th power. And so what's going to happen with those? Well, we've got these division here. And when we divide, the exponents subtract. And watch out for the double negative. So we've got t to the 24th power minus a minus 4. The double negative here, what happens with it? It becomes positive. So that comes out to be t, adding them together, to the 28th power. So let's do it in small pieces here. And what's our final answer then? We got rid of the t's, right? So we now have 11 t to the 28th power on top. What about down below? Down below, we've got that 10,000. So we distributed through. And over to the side, we worked with our parentheses. We used our quotient rule and our power rules to work those out. And we got our final answer. Now, how do we know we're finished? Well, 11 divided by 10,000 does not come out as a nice fraction. So we leave it as it is. And there's no more t's to go together. And all of our powers are positive. So you got to watch and make sure you've got no variables that go together. All positive exponents. Make sure you can't reduce that down at all with the fractions. 11 over 10,000 is not going to reduce. I think that one is a little bit more difficult than 14 and 15. And students always kind of struggle with these because they're just different. What about the next one? The next one we've got 2x cubed y to the negative third all over x to the negative fifth y to the fourth power. Thank you, Josephine. To the negative second. And again, there are many, many ways to work this one out. You could just distribute that negative through first, that negative 2 through, but I think that would be more confusing than just reducing down the fraction at the beginning. So let's order of operations. Let's do our parentheses first. So we're going to work with the x part. And what do we have for the x part? We have x cubed over x to the negative fifth. And that's going to be x to the 3 minus 5. And we know the double negative here is going to make that positive. So that comes out to be x to the 8th. There's that piece. All we did was we subtracted them. Double negatives make that positive, and they go together. What about the y part? On the y part, we have y to the negative third over y to the fourth. We're going to again subtract them. So we've got y to the minus 3 minus 4 power. And that makes it y to the negative 7. Is everyone okay with that so far? So we did the x part with the quotient rule. We did the y part also with the quotient rule. Now we can distribute that negative 2 through. That's going to be our next step. And that's going to be 2 to the negative second power. Then we've got x to the negative 16th power. Negative and negative makes that y to the 14th power. Can we have negative exponents? No. Okay. So what about that 2 to the negative second power? We'll do it first. Okay, 2 to the negative 6th power, negative second power. That's the same thing as 1 over 2 squared. And we know that 2 squared is 4. So that's going to come out to be 1 over 4. We don't need the 1, so we'll just put the 4 down below, because that's where that piece went. We rewrote that. What about x to the negative 16th? Can't have a negative power, so it goes down below. And what about y to the 14th? Does that change at all? No, it's positive, so it stays on the top in the numerator. Just do it step by step. Take your time. Work everything out and get to that point. How do we know we're done? Well, y's and x's can't go together. No negative exponents. That's all we can do. And you'll see some more exponents in college algebra. Not quite as many and not into this detail, but we need to make sure we understand the process so when you see them again in college algebra, it's not so confusing. So 15, I think, is easier than the last two, as long as we're careful with it. And this is going to involve our quotient product, and the power rule. Okay, so the first thing I'm going to do is I'm going to work with my parentheses. Then we'll use the quotient rule and the product rule together. So we'll then combine exponents by either adding or subtracting, depending upon what we have. So power rule first. So what do we know about these two? They multiply. Those multiply as well. Remember, whenever you have parentheses, those exponents multiply. So now we've got 18 r to the fourth, r to the negative sixth power over 7, r to the negative 10th power. So all we did there was just multiply with those parentheses. And you can do this all in one step if you want for the next part. I'm going to break it up. And I'm going to look at the numerator of the top half. And what do we have in our numerator for the r's? We have an r to the fourth, r to the negative sixth, so those can go together. And that's r to the 4 minus 6, which is then r to the negative second power. Okay, so I just put those together. Is everyone okay with that? And you could have done it all at once. You could add them and then subtract at the same time. I think it's easy if you break it up a bit. So we took our parentheses, multiplied those exponents together there in green here. Then we combined the numerator and the top half together over here. And now what do we do to finish it out? Now we use our quotient rule. So we now have, for the next part, r to the negative second over r to the negative 10th power. We're dividing, so we subtract. Watch out for double negatives. So that's r then to the minus 2 minus a minus 10. Double negative here is going to make that positive. So that comes out to be r to the 8th power. So now we've got our final answer, which is 18 r to the 8th power over 7. So we just worked with everything. We combined all of our like terms together, moved things around, and that's our final finished answer. And that one I think was a little bit easier than 13 and 14. I think 13 was probably the hardest, and 15 was probably the easiest one of these three. So is everyone kind of okay with what we did there? So what is our main takeaway? When we have parentheses, what do? Multiply. Exponents multiply with those parentheses. When we have no parentheses, what do? When we apply the product rule, that means they're back to back, they add together. When we divide, we use our quotient rule, so we subtract. We make sure then that our answer has no negative exponents, and make sure we can't reduce it down any further. We did have a few questions out of 4-4 to look at next. So 4-4, we're going to look at question 2. And these are multiplying out the polynomials. So question number 2 in 4-4 is minus 2x plus 4y times 3x plus 11y plus 1. And we need to make sure we know how to multiply these. Very, very important for the rest of this course and also college algebra. So we cannot FOIL this out. Why not? 2 terms here, 3 terms here. So it's too big to FOIL. So how do we approach it when it's too large to FOIL? Make our box, and then multiply to fill it in. So let's go ahead and make our box here. I always like to write the larger one across the top, smaller one down the side, but it doesn't matter either way. Just one goes across the top, one goes down the side. So that is 3x, 11y, and 1. And then down the side is a minus 2x and 4y. We make our box. And how do we fill in the box? We multiply. So the box gets filled in by multiplying. 3 times a negative 2 is a negative 6. And x and another x makes it x squared. So that's a minus 6x squared there. Next, we've got a minus 2 times a positive 11. So that makes it a minus 22. X and y can't go together. So that's just a minus 22 xy. And then negative 2x times 1. Well, that's just itself, which is a minus 2x. Now we repeat the process on the next row. 4 times a positive 3 is a positive 12. X and y can't go together. So we just go like that. So they're just combined together there. What do we have next? Next we have 4 times 11. So that's 44. Y and another y makes it y squared. And then 4y times 1, that makes it then 4y. So we just got all the pieces by multiplying.
So you can either do on the 12 xy, you can do xy or
yep,
y.
doesn't matter.
Okay.
Yep, they're the same. Doesn't matter whether you write the y first or the x first. That's irrelevant. It's just xy or yx, either one. Now, where do we begin? When we combine like terms, we always start in the upper left corner. And the upper left corner is a minus 6x squared. So that is gone. A lot of times, but not always, you can add on the diagonal. Okay, this one has a diagonal we can add together. These are the same. Minus 22 plus 12, that makes it a minus 10 xy. Gone and gone. Now the next diagonal here, those can't go together, can they? Right? Because one's got an x, one's got a y squared. So those are going to remain separate. So those cannot be combined together. So that's a minus 2x and a plus 44y squared. And then the very last piece is simply a plus 4y. And if you use...
If the negative 2x comes first?
No, it doesn't. It does not. Because it's all the same. Remember, addition is community. Order doesn't matter. Now, normally when we write these, though, we want to pick a power and make sure we go down in that power. So we started with x. So we have an x squared here. That's our largest power. And we've got, from there, it doesn't matter so much. Then we've got an xy, a minus 2x. And then we'll do the y's after that, which is 4y squared. Or sorry, 44y squared and a 4y. So it doesn't matter about the order, as long as all the terms are there. But normally we start with the highest power of x first. So order is not important because it's community. Question 4. Question 4 is not going to require the box method. So question 4 is a little bit easier because we can simply FOIL. Now, how do I know that I can FOIL? Well, we use the FOIL method when it's 2 by 2. 2 terms here, 2 terms here. So we know then that we can apply our FOIL method. If you want, you can draw the arrows out. But you're going to get 4 parts to this one. We're going to use the FOIL method. First times first is 3x times another x. That makes it 3x squared. Outside and outside, so that's 3 times 9. That makes it 27x. Inside and inside, that's a minus 11x. And last is a minus 99. So we FOILed that out. Always check then to see if we can combine like terms together. And it looks like those can combine together, right, in the middle. So our final answer would then be 3x squared. 27 minus 11, that makes it 16x. And then a minus 99. And that's as far as we can go. Why can we not go any further? That's an x squared, so they cannot link together. They're separate, so you have to keep them separated out. So we used the FOIL method, and then we added the middles together because they were like terms. Question 6, we're going to be using the distributive property. So question 6, we've got a minus 11, x squared, times a minus 11, x to the 4th, plus 7x cubed, plus 4. Sometimes students get confused as to what we need to do here. So we've got 3 different methods: the FOIL method, the box method, or we can distribute through. Now, this is going to be a distribution. Why is it just going to be a simple distribution? Because there's no addition here, right? It's one single piece. So all of this right here in front, there's no addition, no subtraction. So what we can then do is we can distribute it straight through. You only have to FOIL or use the box method when that first set has got parentheses around it. It's got addition or subtraction. So this one is just a straight distribute through. And then negative and negative makes it positive. And 11 squared, I believe, is 121. I always like to double check myself. So that's 121. Doesn't matter whether you write the a first or the x first. They already have the a first, so we'll just write it first. How many of those do we have? We have 1, and another a makes it a squared. And then what about the x's? We've got 2, add 4 more to it, so that makes it x to the 6th. Because the exponents add. If there is no number, what do we know is here? If there's no number, there's actually a 1, right? And that 1 and 1 makes it the 2. 2 and 4 makes it the 6. Negative 11 times a positive 7. That makes it a minus 77. No other a's, so we just have that single a there. What about the x's? We've got 2, add 3 more to that. And that's going to make that x to the 5th. The last and final piece is negative 11 times 4. That makes it a minus 44. Nothing else to go together. So that just brings down the a and the x squared. And what we're going to be doing today is we're going to be learning how to factor, which is basically doing the opposite of what we just did. So instead of distributing through, we're going to be factoring or pulling things out. So we need to know how to multiply before we can factor. If there's no other questions, then we'll move on to 5.1. And Chapter 5, I think, is one of the most important chapters. We're going to spend the rest of our time working in Chapter 5. We should be able to finish it, I'm hopeful, because these do take a lot of time to go through, but very, very important that we are really good at factoring. To be successful in college algebra, you need basically 3 skills. You need to be able to solve applications like the mixture, the investment, the distance problems. We did those. You need to know how to graph lines, plot points, find line equations. We did that. And you also, to be successful, need to know how to quickly factor and multiply polynomials. So as long as you have those 3 skills, you'll be successful in college algebra. And we already have 2 of them. We're learning the last one right now. Chapter 5 is all about factoring. And when we factor, it's almost like working with a puzzle. And we take out what's in common. And the reason why we do that is later on, you're going to see how things can go together. Our main goal is to try and get the exponents down as small as we can. So when we look at these, we need to factor out numbers and reduce the variables down as far as possible. So we're now going to look at 5.1, and we're going to learn now how to factor out the greatest common factor. So we're going to try and factor out the greatest common factor. These are what they have in common. And we're going to start off with a very, very easy one. Okay, so we're going to try and factor out what is in common. And we're starting with some simpler ones, and then we're slowly working our way up to some of the more complicated ones. Now, what we do is we look at everything together as a whole, and we see what's in common. We see if there's a number that's in common with both of these, 4 and the 12. Well, what do a 4 and a 12 have in common? They're both factors of 4, right? Okay, so we're going to be factoring out a 4. When we factor something out, that's dividing. So we factor out the 4 because a 4 and the 12 both have a 4 in common. So the 4 is going to come out. Now we rewrite what's left over. This is the opposite of what we just did. So what we did last week, we're doing the opposite. Instead of distributing it through, we're factoring it out. So now we need to fill it in. So we took the 4 out in front. 12 divided by 4. What's 12 divided by 4? 12 divided by 4 is a 3, and the x comes down. What about the next piece? We just divide 4 divided by 4. What's 4 divided by 4? 1. So that would factor into a 4 out in front and a 3x plus 1 inside. We're just learning the very, very basics. If you distributed that 4 through, it would give you the same result. Because if you distributed that 4 through, 4 times 3 is 12x there. 4 times 1 is 4 there. Let's try to factor out another one. This one we're going to have to also factor out a variable. This one, we're going to do the same process. We're going to factor out the greatest common factor. So the first thing that we look at is we look at the numbers. I've got a 40, a -5, and a 10. What goes into all of those? The largest number that goes into all of them is going to be a 5, right? Because 5 goes into 40 8 times. 5 goes into 5 1 time itself. And that 10 divided by 5 leaves you with a 2. So we're going to factor out a 5. And then we look at the x's. They all have an x in common. So we're going to factor out an x. So what's going to come out is a 5x. And then we divide. Exponents are going to subtract. So we factor out the x because they all have it. Always take out the lowest power of your variables. So if they all have the same variable, you take out the lowest one. So let's work on this one. Okay, 40 divided by 5. Well, 40 divided by 5, that leaves you with an 8. X cubed, we're taking out an x, so that leaves you with an x squared. -5 divided by 5. Well, -5 divided by 5 is a -1. You don't need to write the 1. You can, but we're not going to in this case. And then what about the x's? We've got 2. Take out 1. That leaves you with that minus x. And what about the last piece? Well, 10 divided by 5 is a 2, and the x's will come out and cancel out. Again, we're just going to slowly increase the difficulty until we're comfortable with factoring out the greatest common factor. A lot of times the directions will just say factor. So let's make this one a little bit more difficult. This one's going to have more variables. So we're going to try and factor this one again. And so we look at our numbers first. 9, 18, and 3. What do they all have in common? Can anyone tell me what number I put out front? 3. Okay, so the 3 is going to come out front. So that comes out here. Then we look at our x's. X cubed, x squared, x. We always use the smallest one, so we're going to factor out an x. Then we look at the y's. Use the smallest power. We've got a 5, a 4, and a 3. So we would factor out a y what? Cubed. Factor out the lowest number for each variable. Then we start dividing. 9 divided by 3. 9 divided by 3, that's a 3. How many x's do we have? We have 3. Take out 1. That leaves you with an x squared. What about the y's? 5. Take out 3. That leaves you with a y squared. Because 3 and 2 makes it 5. They have to add together to give you the original. 18 divided by 3. Well, it's going to be a negative. And 18 divided by 3, that's a 6. And then we've got x squared. Take one of them out. So that leaves you with an x. Y to the 4th. Take 3 of them out. That leaves you with a y. And what do we have left? 3 divided by 3, that's a 1. The x's are gone, the y cubes are gone. If it all goes away, you leave a 1. Now, when you start, you've got 3 terms. 1, 2, 3. Inside that parentheses had better be 3 terms as well. 1, 2, 3. So make sure you start with the same number of terms that you end with. Also, if it begins with a negative, you always want to factor out a negative. So again, we're going to factor. And this one's going to be a little bit smaller. We've got different variables, and we need to see what can come out. Now again, the standard way of working with these is if it begins with a negative, we have to factor out that negative. That's just going to make it easier later on. So it begins with a negative, so we have to factor out that negative. Now, what about numbers? 5 and an 8. Do they have any number in common? No. So there's no number in common. It begins with a negative, so we've got to factor out a negative. What about our x's? We've got a 5 and a 3. Smaller one is a 3. So that makes it an x cubed. It's going to come out. What about the n's? 4 and 2. Always take out the smaller one. So we're going to take out an m squared. Now, whenever you take out a negative, that's going to change your signs because you're dividing by a negative 1. So negative 8 divided by negative 1, that makes it a positive 8. We've got an x to the 5th. Take out 3 of them. That makes it an x squared. How about the n's? We've got 4. Take out 2. That makes it an m squared. 5 divided by negative 1. That makes it a negative 5. X cubed is already taken out. M squared is already taken out. So that's as far as we can go on that. So that would be your factored, finished answer. We'll do a couple more, and then we'll take a short break. You can also factor out parentheses if they have them in common. So we're going to try and factor this one out. Now, the same way that we can factor out variables, we can also factor out groupings. We can factor out entire sets of parentheses as long as they are identical. So what's going to happen here? Well, we have an a minus 7 and an a minus 7, right? So that a minus 7, that's going to come out in front because they're the same. And I was just lightly cross it out so we don't get that confused. So that's gone. Now we write what's left over and we try and condense it down. And a lot of times when I know I've got to do more work, I use square brackets. And so what do we have left? If I take those two pieces out, okay, they're gone. They came out. The a minus 7s are gone. What's left over? 4x plus 3 and 2x plus 5. So those were gone. So that's there. Now, once we've got the leftovers, again, I like to use square brackets. That way we don't have all these sets of parentheses running around, and so it's not so confusing. Now let's see what we can do. Inside, we need to clean this up a bit. So we have a 4x and a 2x. Those can add together right here and right here to make it 6x. And then a 3 and a 5, that gives you an 8. Okay, so we got to this step. Now we may be able to go one more step. Always check and see what you've got left over. See if there's a number or a variable that can come out. So let's look at our square bracket here. We've got a 6 and we've got an 8. So 6 and 8 have what in common? 6 and 8 have a 2 in common, don't they? So I'm going to now take a 2 out, and I'm going to put the 2 clear in the front. And that leaves me with, still, a minus 7. And now that we've gotten everything factored out, we can use our parentheses. We factored that 2 out. 6 divided by 2 makes it a 3x. 8 divided by 2 makes it a 4. Now, how do we know that we need to stop? Well, we know we need to stop because we look. A minus 7. Can anything come out of an a minus 7? Do they have any factors in common? No. 3x plus 4. Do they have any factors in common? No. Nothing can be combined together, so we now know that we can stop. Let's try another one. They're all a little bit different, but they use the same process. About 5x times 3a plus 2, quantity squared, minus 4 times 3a plus 2 here. So when we look at this, think of the parentheses as one item. And if the parentheses are the same, it can come out. So these both have a 3a plus 2 in common. They both do. So we're going to now take out that 3a plus 2. When we write this, we have to be very careful about what is left over. So a 3a plus 2 came out. Now this one has 2 of them because it's quantity squared. So this one is going to be left with your 5x, and then this is squared, so we took one of them out. So 3a plus 2 is still left over. The second piece, what's going to happen here? Well, the 3a plus 2 came directly out. It's not squared, so it's gone. So that leaves you then with a minus 4. Because there's 2 of them. I took one of them out, and one of them is left over. Second piece, that's completely gone. So that just leaves you with a minus 4. Now we need to clean this up as much as possible. We need to get rid of all the extra parentheses. So we're going to use our distributive property here. And we're going to distribute that 5x through. And that leaves you then with a 15. 5 times 3 is 15. XA, or AX, doesn't matter the order. Will be irrelevant here. 5 times 2 is a 10x, and then a minus 4. And we don't need the square brackets because we brought it down as far as we could. Nothing else will combine together. And what's still left in front? 3a plus 2. Now, why can I not break this down any further? Well, 3 and 2, do they have anything in common? No. 3 and 2 in my first set have nothing in common. What about the next set? 15. And I think I put too many x's here. Yep, that was my mistake. There should just be one x there when I distributed it. I don't know why I put the double. There should just be one x there. Sorry about that. Okay, so on the next one, I've got a 15. I've got a 10 and a 4. 15, 10, and 4. Anything in common? No. Nothing, no number will come out of there. Then we look here. This one has an x, this one has an x, but that one does not. So x's can't come out. This one has an a, nothing else does. Nothing can come out there. So that is as far as we can go. And it will get easier the more of these you do. For college algebra, though, you need to be able to factor pretty quickly. Let's just do one more real quick here. And then we'll take a short break. So we'll take a break after this question. And there are different ways of doing this. You can factor all of it out at the very beginning. You can factor it out at the end. I like to factor it out at the beginning. So let's see what we've got. Let's look at the numbers in front. We've got a 4 and an 8. So 4 and an 8, they're both divisible by 4. Then we've got 3x minus 2. Now we always take out the smallest power. So this one is cubed, this one is squared, so we take out the smaller one, so we're going to have to take out a 3x minus 2 quantity squared because it's the smaller one. So always take out your smallest power. Now we've taken all of that out. Let's write what's left over. So let's begin with the 4. So the 4 came out. So 4 divided by 4. 4 divided by 4 is 1. We don't write that 1, but it's there. So that came out. A squared, there's nothing else coming out with that. So that's going to leave you with an a squared. What's happening here? We've got 3 of these, of the parentheses. We're taking out 2 of them. So that leaves you then with 3x minus 2. Next, we've got the 8. 8 divided by that 4 in front. 8 divided by that 4 leaves you with a 2. This is squared, so it's gone because we took 2 of them here. 2 of them came out. Almost finished. Distribute that a squared through. So go ahead now and distribute that a squared through. And that's going to give you 3x a squared minus 2a squared plus 2. And that's going to now be our final, finished, factored answer. We took out that 4, because of 4 and the 8, so we took that 4 out. They had a 3x minus 2 quantity squared in common, so that came out with that 4. Then we took the 4 and the 8. 4 divided by 4 was 1, so that's gone. That left you with the a squared. We took out the 3x minus 2. Got them squared here. We've got 3 of them, so we took out that, left you with 1. 8 divided by 4 leaves you with a 2. The 3x minus 2 is squared. We're taking out 2 of them, so it's gone. Then we distributed the a squared through. Nothing combined together, and we're done. Now, why can I not factor anything out of here, out of this last set? What are my numbers? 3, 2, and 2. 3 and 2, there's no number that evenly divides into either one of them, is there? Right? Because you've got a 3 and a 2. Nothing will go into either one of them. Nothing comes out total. Because 3 and 2 are both prime numbers. Nothing comes out, so I cannot factor anything out. So that's as far as I can possibly go. And I know they're kind of confusing right now, but once you do a lot of these, they're going to get a lot easier. It's all pretty much the same. Factoring is just undoing that multiplication. So let's take a short break, and let's meet back at, how about 9:45? So let's meet back here at 9:45.